So we have here a table for pile type with corresponding value for K. So the values of the small delta from various routes of investigation appear to be in the range from 0.5 of phi prime to 0.8 of phi prime. So basically you have also here the value for K for different pile type according to Mansur and Hunter. So according to Coyle and Castillo, in conjunction with the material presented in the previous section, our Q sub S is equal to this equation, wherein our sigma sub O prime is the average effective overburden pressure and small delta prime is our soil pile friction angle, 0.8 of phi prime. And of course, our lateral earth pressure K can be determined from the field observation using our figure 9.17. So if you're going to make use of that figure, if we're going to make use of this figure 9.17, the value for our Q sub S is equal to this equation. So we move on now to correlation with standard penetration test result. According to Mayer-Off, he indicated that the average unit frictional resistance Fs of AB for high displacement driven pile may be obtained from the average standard penetration resistance value. So using this equation, of course, our N sub 60, that refers to the average value of the standard penetration resistance, and we have our atmospheric pressure P sub A. For low displacement driven pile, you have this equation, and according to Bryod and his company, suggested that the unit frictional resistance F sub AB is approximately equal to this equation, and therefore our skin friction or frictional resistance is equal to P perimeter times the length times our unit frictional resistance. The correlation with cone penetration test. So according to Nottingham, he provided the correlation for estimating the Q sub S using the frictional resistance that was obtained from the cone penetration test. So if you're going to compute for the unit frictional resistance obtained from the cone penetration test, you have this equation. So the variations of our alpha prime with the embedment ratio for electric cone and mechanical cone penetrometers are shown in our figure. From this figure, these are the variation of alpha prime with our embedment ratio for pile in sand. This is for electric cone penetrometer. So basically, that is now our skin friction will be equal to this equation. Of course, you have the summation of P. We have our delta L times our F, or that can be equivalent now. This equation will be equal to the summation of P times delta L times alpha prime times our F sub C. F sub C is the frictional resistance that was obtained from cone penetration test. So we have here a sample problem. Consider a concrete pile that is 0.305 meters by 0.305 meters in cross-section in sand. The pile is 12 meters long. The following are the variations of N60 with depth. So for this one, we are given with our variations of our N sub 60 that corresponds to every depth. So we're going to estimate the Q sub S, our skin friction for the pile. We have to consider the result of the previous problem. We have determined the allowable load capacity and of the pile based on Mayer-Off method and Broad's method. So we use the factor of safety, which is Fs equal to 3. So for this one, since we are given with the standard penetration numbers, we get the average N sub 60 value for the sand for the top 12 meters. So using the top 12 meters depth, the N sub 60 will be up to this point. So that is 8, 10, 9, 12, 14, 18, 11, and 17. So we have here all over. These are all over 8. So we get the average value of N sub 60, which is 10.25, approximately 10. So therefore, our unit frictional resistance equal to this equation, and that is equal to 20 kilonewton per meter squared, and our skin friction will be equal to 292.8 kilonewton. And For an equation using this equation, so we simply have our unit frictional resistance equal to 43.68 kilonewton per meter squared, and our Q sub S now is 639.5 kilonewton. So based on Mayer-Off method, our allowable load capacity would be Q sub P all over Q sub S all over Fs. So basically, from our previous discussion, from our previous problem, we have solved for our Q sub P, which is 633 plus this now Q sub S equal to 3. So you have 308.6 kilonewton. Based on the Broad's method, our Q allowable is equal to 508.2 that was solved in the previous example for Q sub P plus 392.5 all over 3, that gives us 382.6 kilonewton. So therefore, the allowable pile capacity can be taken to be 345 kilonewton. You get the average of this. So 308.6 plus 382.6 divided by 2, you get 345 kilonewton. So we have a sample problem number 2. Consider an 18-meter long concrete pile with a cross-section of 0.305 meters by 0.305 meters, fully embedded in a sand layer. For the sand layer, the following is an approximation of the cone penetration resistance Q sub C for mechanical cone and the frictional resistance F sub C with depth. Estimate the allowable load that the pile can carry. Use F sub S equal to 3. So for this one, we're given with the depth from the ground surface, we have Q sub C and our F sub S. And therefore, to get our Q sub U, of course, that is equal to Q sub P plus Q sub S. And our small Q sub P is approximately equal to Q sub C. And that is equal to, at the pile tip at the depth of 18 meters, Q sub C is equal to 9,500 kilonewton per meter squared. So therefore, you can compute now for our point bearing capacity equal to this equation. Simply have to substitute the area and our Q sub C. It gives us 883.7 kilonewton. So we're going now to determine our Q sub S. So the summation, we have to sum up our Q sub S. So we have given with the depth from 0 to 5, 5 to 15, 15 to 18. So we can tabulate this one. You have to take note that the embedment ratio is 59. So this is delta L, change in depth. So 5, 10, and 3. F sub C is given alpha prime from figure 9.19. So that is 0.44. We're given with our embedment ratio, which is 59. So therefore, using this formula, P delta L alpha prime F sub C, you simply have to multiply all of those. And you try to sum up this one. You have now your Q sub S skin friction 1107.35 kilonewton. So therefore, since you have now Q sub P and Q sub S, you have now the ultimate load bearing capacity for the pile, which is 1991.05 kilonewton. So our allowable bearing capacity would be Q sub U all over Fs, which gives us 663.68 or approximately 664 kilonewton. Now we move on to the frictional skin resistance in clay. So for this frictional skin resistance in clay, we have here method. We have 3 methods actually: Lambda method, Beta method, and Alpha method. So let's start with Alpha method. So in this method, this was proposed by Vijay Bergaya and Vogt, which is based on the assumption that the displacement of soil caused by pile driving result in a passive lateral pressure at any depth, and the average unit skin resistance is given by this equation, wherein we have here our lambda. This is equal to the mean effective vertical stress for the entire embedment length. This is our mean undrained shear strength. For phi is equal to 0. And we have here the variation for our lambda based on the value for our embedment length. So the frictional resistance, therefore, would be equal to this equation. We have to take note, if we are given with a layered soil, like for example, in this one, we have this is a figure showing to us the application of Lambda method in layered soil. So you have our pile. So of course, you have now, with respect to the depthness, we have our undrained cohesion, and you have your vertical effective stresses. We have our pressure diagram for we're given with the area 1, area 2, and area 3. So for that one, using that figure, according to that figure, the mean value of our C sub u is equal to C sub u for layer 1 times L sub 1 plus C sub u for layer 2 times L sub 2, and so on, all over the total length of the pile. Similarly, in our figure C, for this one, the plot shows of the variation of the effective stresses with depth. So meaning to say, the mean effective stress sigma sub O prime is equal to the areas divided to our length of the pile. So those are areas of the vertical effective stress diagram. So for the Lambda method, according to the Lambda method, the unit skin resistance in clay soil can be represented by this equation, wherein alpha is the empirical adhesion factor. The approximate variation of the value of alpha is shown in this figure. So we have here the variations of our alpha. We just need to know the ratio between our undrained cohesion with respect to the atmospheric pressure. So for alpha, that is, can actually be a function of vertical effective stress and the undrained cohesion. So slated shows that alpha is equal to capital C times sigma sub O prime all over C sub u raised to 0.45. Our C is approximately ranges from 0.4 to 0.5 for bored piles and 0.5 for driven piles. So a correlation that was proposed by Randolph and Murphy was incorporated into the code of API, and he has identified that alpha is equal to this equation, wherein C sub u over sigma sub O prime should be less than or equal to 1, and our alpha is also equal to this equation when C sub u over sigma sub O prime is greater than 1. It was further modified by the API that our unit frictional resistance is equal to this equation or to this expression, whichever is larger in value. So Karlsruhe proposed an alternative relation for alpha that is shown as by NGI method. According to this method, alpha is equal to this expression for alpha which is less than or equal to 1 but greater than or equal to 0.2. This is for C sub u over sigma sub O prime less than or equal to 0.25, and alpha is equal to 0.5 for C sub u over sigma sub O prime is equal to 1. So the term alpha has a log linear relationship with our C sub u over sigma sub O prime between C sub u over sigma sub O prime, which is equal to 0.25 and 1. For C sub u over sigma sub O prime greater or equal to 1, the value of alpha is equal to this multiplied to C, where C is our correction factor. So the interpolated values for alpha for open-ended and closed-ended piles are given in a certain table, which is in table 9.21. So we have here the value for alpha, having the value of C sub u over sigma sub O prime. And the ultimate resistance is given with this equation. So this is now the value for the skin resistance, which is equal to the summation of Fp delta L or summation of alpha C sub u P times delta L.